Welcome to The Explainer. Today, we're going to talk about something that's kind of invisible, but it runs pretty much everything: process measurement. It's the hidden bedrock for countless decisions, and when it's shaky, well, the consequences can be massive. So let's get into why this is so critical.
So let me just start by asking you this, straight up. Can you trust your tools? And I don't just mean a screwdriver or a wrench. I'm talking about the stuff you really lean on, the data, the dashboards, the numbers you rely on every single day to make big calls. How sure are you, really sure, that they're telling you the whole story?
Because here's the deal. Every single decision you make depends on the quality of that information. If your measurements are a little bit off, your decisions are going to be off too. It's that simple. Without that solid foundation, we're all basically just guessing, and the stakes are incredibly high.
Okay, so that leads us right into our first big topic: why measurements can lie. It's not that your data's out to get you, but it is far from perfect. Let's break down the two main ways things can go wrong.
You know, our ability to measure anything really comes down to two things. First, there's the accuracy of the tools themselves. Is that scale actually calibrated? Is that software up to date? And second, and this one is a huge one, good old human error. Look, we all make mistakes, but even a tiny slip-up when you're taking a measurement can create a massive ripple effect down the line.
Now, this is so important. We've got to talk about two words that people use interchangeably all the time: accuracy and precision. They are not the same thing. Think of it like throwing darts. Accuracy is hitting the bullseye. It's how close you are to the true value. Precision, on the other hand, is all about consistency. It's getting all your darts clustered together in a tight little group, even if that group is way off in the corner. The goal, of course, is to have both. You want to hit the bullseye every single time. So the big question is, how do we fight back against this faulty data? How do professionals make sure their measurements are both accurate and precise? Well, that's where a really powerful quality tool comes into play. It's time to meet the Gauge R&R.
A Gauge R&R study is basically a formal investigation of your entire measurement system. You can think of it like a full-blown audit for your data collection process. Its one and only purpose is to figure out if you have a measurement problem, and, if you do, just how big that problem really is. And the secret is right there in the name. R&R stands for repeatability and reproducibility. Repeatability tests one person's consistency. If I measure the same thing 10 times, do I get the same result? Then there's reproducibility, which tests the team's consistency. If 10 different people measure that exact same part, do they all get the same result? For a system to be trustworthy, you absolutely have to have both.
And you don't always do these studies the same way. It depends on the situation. In a crossed study, every person measures every single part. It's super thorough, but you do risk what's called a carryover effect, where one measurement might subconsciously influence the next. Then you have a nested study. In this one, each person measures a totally unique part. This is absolutely essential for things like destructive testing. I mean, you can't have 10 people test the same car airbag, because after the first person tests it, well, it's gone.
Okay, I know we've been pretty deep in the technical weeds here, but why does any of this stuff really matter? The answer is actually pretty simple. In any process, the customer is everything.
And to make sure we stay focused on them, we use a kind of special language. We always start with the voice of the customer, or VOC. What do they actually want? From there, we figure out what's critical to quality, or CTQ. These are the absolute non-negotiables. And finally, we have to listen to the voice of the process, or VOP. That tells us what we're actually capable of making. The whole game is just trying to make the voice of the process perfectly match the voice of the customer.
This brings us to a really core concept: value. An activity is only value added if two things are true. One, the customer thinks it's valuable, and two, they're willing to pay for it. If an activity doesn't pass both of those tests, it's considered waste. It's a beautifully simple and kind of ruthless way to filter everything you do.
So what happens when we fail? When our measurements are wrong, our processes are wasteful, and we don't deliver what the customer actually needs? Well, that's when we come face to face with the immense cost of failure.
Professionals have a name for this: the cost of poor quality, or COPQ. It's a really powerful idea. It represents every single dollar that you would not have spent if your process had been perfect from the get-go. This is the true price of not checking your tools, of skipping that Gauge R&R study, of letting those little measurement errors slip through the cracks.
To really get a sense of just how high that cost can be, we need to look at a tragic, real-world example: the Boeing 737 MAX.
At the heart of the disasters was a faulty flight control system. But this wasn't just a software bug. At its core, it was a measurement failure. The system relied on data from a single sensor, a single tool that wasn't accurate. And the system wasn't reproducible enough to catch that error. The consequences were absolutely devastating.
The human cost was, of course, immeasurable. And the financial cost of poor quality for Boeing, it ran into the billions of dollars. This is maybe the most powerful illustration out there of why getting measurement and process right isn't just a technical exercise. It is a critical responsibility.
So how can we avoid these kinds of failures? How can we actually see the waste and the risk that might be hiding in our own work? Well, the final step is to start mapping out the process, to make the invisible visible. And there are 3 fantastic tools for this. First, you've got a spaghetti diagram, which literally traces the physical path people and things take, and it instantly reveals all the inefficient, wasted motion. Next, there's a classic process map, a flowchart, that shows the sequence of steps and decisions. And finally, maybe the most powerful of all, is the value stream map, which visualizes the entire flow from the supplier all the way to the customer, highlighting exactly where value is being created and where it's being lost. This chart really nails the difference between a process map and a value stream map. A process map is tactical. It's zoomed in. It's great for understanding the nitty-gritty steps of a single task. But a value stream map, a VSM, that's strategic. It's the 30,000-foot view. It shows you the entire system, including data on time, inventory, and information flow, forcing you to see the big picture. Here's a great way to think of it. A process map helps you do the thing right, but a value stream map helps you do the right thing.
So, as we wrap up, I'll leave you with this question to think about. Think about your own routines, at work or even at home. Where is the hidden waste in your daily process? Once you start looking for it, you'll be amazed at what you find. Thanks for watching.